In this lesson, you will learn how to add and subtract fractions. For the first 10 problems, all of the denominators will be the same. So when you're asked to add 3/7 plus 2/7, since both of the denominators are 7, we can write this as one fraction, 3 plus 2 over 7. The denominators don't add together, and the answer is 5 over 7. For number 2, 4 over 9 plus 11 over 9, both denominators are 9, so we would take the numerators of 4 plus 11 over 9, add the numerators together, and we get 15 over 9. Now in this example, when I write the prime factorization of 15 and the prime factorization of 9, since they both have a factor of 3 in common, they cancel, so that the final answer is 5/3. Now this can also be written as a mixed number since the numerator is larger, and to change 5/3 to a mixed number, I divide 3 into 5. 3 goes into 5 once, with 2 left over. So 5/3 is the same as 1 2/3. For number 3, -3/5 plus -2/5. Both denominators are 5, so I can write this as -3 plus -2 over 5. And if we take -3 plus -2, we get -5 over 5. And anything over itself is 1, but because the numerator's 5 is negative, the final answer is -1. Now for number 4, we have two mixed numbers, -6 1/12 minus 3 5/12. So to subtract these mixed numbers, the easiest way will be to change them as improper fractions. So 6 times 12 is 72. Add the 1 and we get -73 over 12. And then 3 5/12, I take 3 times 12 is 36, plus 5 is 41, so we have -41 over 12. Both denominators are 12, so I have -73 minus 41 over 12. -73 minus 41, if I do keep change change, it's now -73 plus a -41. Which is equal to -114 over 12. So to simplify -114 over 12, I write the prime factorization of both numbers, so that -114 is -2 times 3 times 19, and 12 is 2 times 2 times 3. The 2's cancel, and as an improper fraction, -3 times 19 is -57 over 6. But then I can convert this into a mixed number, and 6 times 9 is 54. So negative 114 is negative 2 times 3 times 19, and 12 is 2 times 2 times 3. I can cancel the 2's and the 3's, so that as an improper fraction, my answer is negative 19 over 2. And if I convert this into an improper fraction, 2 divides into 19 9 times, and when I subtract I have a remainder of 1, so as a mixed number it would be negative 9 and 1/2. So both of these answers are correct. For this problem, the negative 9 and 1/2 would be a better way of expressing your answer because the original question fractions were as mixed numbers. For number 5, 1/3 minus a negative 2 2/3. So we have 1/3 minus, if we change negative 2 2/3 to an improper fraction, 2 times 3 is 6, plus 2 is 8, so we have 1/3 minus negative 8/3. The denominators are the same, 1 minus negative 8 over 3. If we do keep, change, change, the two signs that are negative change to positives. So that we have 9/3, and 9 divided by 3 is just 3. For number 6, negative 3 7/8 minus 1 2/8. So I take 3 times 8 is 24, plus 7 is 31. So I have negative 31 over 8 minus 1 times 8 is 8, plus 2 is 10. So I have 10/8. Both denominators are equal to 8, so I have negative 31 minus 10 over 8, and negative 31 minus 10 is equal to negative 41 over 8. So as an improper fraction, the answer is negative 41 over 8, but if I change this to a mixed number, 8 goes into 41 5 times, and I have a remainder of 1, so this can also be written as negative 5 1/8. For number 7, even though this problem has variables, we always look at the denominators first. And since both denominators are 4 and we're adding them together, this problem is just 6x plus 12x over 4, and 6x plus 12x add to 18x. So 18x over 4 is the fraction, but not the final answer, because 18 and 4 can reduce. So I take 18 and write the prime factorization, and I take 4 and write the prime factorization. So if I expand out 18x, I have 2 times 3 times 3 times x, and then 4 is 2 times 2. The 2's cancel, and I multiply together what's left, and I have 9x over 2. These problems with variables you usually don't see written as a mixed number, so I will leave all of the problems that are variables, or that have variables, as improper fractions. So for number 8, we have 3 fractions, but again, all the denominators are the same. So we have negative 4x minus 3x plus a negative 8x all over 9. And if I write down negative 4x minus 3x plus negative 8x and show the work underneath. I start from the left, taking two numbers at a time. Negative 4x minus 3x is negative 4x plus a negative 3x, which is negative 7x. And if I add two negatives, negative 7x plus negative 8x is negative 15x. So I can rewrite this as negative 15x over 9. And then I want to take the two numbers of 15 and 9 and write their prime factorization. So that I have negative 3 times 5 times x over 3 times 3. The 3's cancel, and I multiply together what's left, which is negative 5x over 3. For number 9, negative 4 over 8x minus 12 over 8x. So both denominators are 8x, so I have negative 4 minus 12 over 8x. In the numerator, if I follow keep, change, negative 4 plus negative 12 changes to negative 16x, or negative 16 over 8x. And since I can take 8 and just divide it into negative 16 evenly, I don't need to write the prime factorization, although it wouldn't be wrong if I did. I have negative 2 over x. And the last problem with the same denominators is 5 over 6y minus negative 9 over 6y. So we have a 5 minus negative 9 over 6y. And if I follow keep, change, 5 plus a positive 9 is 14 over 6y. So 14 and 6 will have a factor in common, so if I break up the two numbers as their prime factorization, 14 is 2 times 7, 6 is 2 times 3, the 2's cancel, I multiply together what's left, and I have 7 over 3y. Now the rest of the problems will have different denominators, but the directions are the same, to add or subtract and write each answer in simplest form. So the first thing I want to do is I want to rewrite 4/5 minus 3/2, and then what I want to do is find what's called the least common denominator. And the least common denominator is found by taking my denominators of 5 and 2 and just writing out the first 5 multiples of each. So for 5, I have 5, 10, 15, 20, 25. And for 2, I have 2, 4, 6, 8, 10. The smallest number that they have in common is 10. So that means that the least common denominator, just abbreviated LCD, is equal to 10. So once I determine the least common denominator, on my 5 list, 10 is the second number, so I multiply 5 by 2 and the numerator by 2 as well. On the 2 list, 10 is my fifth number, so I multiply both the numerator and denominator by 5. And by doing this, I change my fractions to 8/10 minus 15/10. And now it's the same as the first 10 problems. I can now write this as 1 fraction over 10. 8 minus 15 is negative 7 over 10. For number 12, I have 5/8 plus negative 4 over 15. So I start by writing the multiples of 8, and then I'll write the multiples of 15. I usually start with the first 5, and if I don't have a match, I'll expand the two lists or only one of the lists. And if I look at these two lists, I don't have any number in common, so I'm going to expand the top list because this one only ends at 40. So my next multiple of 8 would be 48, then 56, then 64, then 72, and then 80, and I'll go a couple more, 88, 96, 104, 112, and 120. For the 15 list, hopefully we'll get a match. And it looks like we have a match with 120. So that means that the least common denominator is equal to 120. So if I look at the list that has the multiples of 8, if I were to count all of these numbers, 120 would be the 15th number on this list. That means that I multiply 8 by 15 and its numerator by the same value. If I look at my list of the multiples of 15, 120 is the 8th number on the list. So I multiply the fraction that has 15 in the denominator by 8. So that my new fractions are 75 over 120 plus negative 32 over 120, and 75 plus negative 32 is 43 over 120. For number 13, I start by rewriting these two mixed numbers as improper fractions. So 15 times 6 is 90. Add the 1 and we have 91 over 6 minus 7 times 10 is 70. Add the 3 and we have 73 over 10. So the denominators are different, so I start by writing multiples of 10 and 6. And for 6, I have 6, 12, 18, 24, 30, and 36. I usually stop at 5 or around 5, or if I get a match, and if I don't have a match in my two lists, I just expand the lists. And on this one, I'm actually going to stop right here because I see that 30 is the least common denominator. And on 6's list, 30 is the 5th number, so I multiply the numerator and denominator by 5. And on 10's list, 30 is the 3rd number, so I multiply the numerator and denominator by 3. So that I have 455 over 30 minus 3 times 73 is 219 over 30. And if I take 455 minus 219. 455 minus 219 is equal to 236. This answer, though, will reduce. So I want to write the prime factorization of 236, and if I divide 236 by 2, I get 118. And if I divide 118 by 2, I get 59, which is prime, so my prime factorization for 236 is finished. For 30, I take 2 times 15, and then 3 times 5, so that I can rewrite my answer as 2 times 2 times 59 over 2 times 3 times 5. Only the 2's cancel, so that I end up with 118 over 15, or I can change this to a mixed number, and 7 times 15 is 105, and when I subtract I get 13 left over, so that this can also be written as 7 and 13 over 15. So for number 14, I will start by writing the mixed numbers as improper. 2 times 4 is 8, plus 3 is 11, so I have negative 11 over 4, plus 7 times 8 is 56, plus 1 is 57. The denominators are different, so I start by writing the multiples of 4 and 8. And the first multiple of 8 is 8. And for 8, the first multiple of 8, which is a match, so my least common denominator is 8. So since one of my denominators is already 8, I only have to multiply the 4 by 2 to make its denominator 8. And I have negative 22 over 8 plus negative 57 over 8. Denominators are the same, so I can write this as negative 22 plus negative 57 over 8, which is negative 79 over 8. And if I take 8 and divide it into 79, I have a remainder of 7. So this can also be written as negative 9 and 7/8. So for 15, we have x over 12 plus x over 8. Even though we have variables in this problem, the process is exactly the same. So I'll take 12 and 8 and write the first 5 multiples of each one. And since I see a match at 24, I will stop my list and say that the least common denominator is equal to 24. And then on 12's list, 24 is the second number, so I multiply the numerator and denominator by 2. On 8's list, 24 is the third number, so I multiply the numerator and denominator by 3. So that I have 2x over 24 plus 3x over 24. Since both denominators are 24, we can take 2x plus 3x, add them together, and we get 5x over 24, which doesn't reduce, so this is our final answer. And for number 16, we have negative 3x over 8 plus 15x over 8, or 15x over 7. And to find the least common denominator, I write out the multiples of the denominators. After a while, you may be able to identify the least common denominator without writing out the list of multiples, and that's okay, but if you're ever stuck, always turn to the multiples and you'll always get the least common denominator. So I'm just going to make this list a little bit longer since we don't have a match. And the next multiple of 8 is actually 56. And we have a match, so the least common denominator is 56. So on 8's list, 56 is the 7th number. And on 7's list, 56 is the 8th number. So I have negative 21x over 56 plus 8 times 15 is 120x over 56. And if I add negative 21x plus 120x, I get 99x. And 99 and 56 do not reduce, so this is your final answer. For number 17, we have negative 2 over 3x plus 4 over 5x. And the x's are in the denominator, so we just take 3 and 5 and just write the multiples of 3 and 5. They both have an x, so you don't have to include the x in the multiple list. You can just write the multiples of 3 and 5. And I have a match of 15, so my least common denominator is 15. And on 3's list, 15 is the 5th number. On 5's list, 15 is the 3rd number. So I have negative 10 over 15x plus 12 over 15x. Denominators are the same, so I have negative 10 plus 12 over 15x, so that the final answer is 2 over 15x. 2 and 15 do not reduce, so this is your final answer. And for 18, we have x over 7 minus 3x over 5. So I write the multiples of 7 and 5. And I don't have a match up to 5, but if I extend the smaller list, or the list that ends with the smaller number, I now get a match at 35. So my least common denominator is 35. So on 7's list, 35 is the 5th number. On 5's list, 35 is the 7th number. So I have 5x over 35 minus 21x over 35. The denominators match, so we can write this as one fraction, 5x minus 21x over 35. And if we do keep, change, change, 5x plus a negative 21x is negative 16x. And if you try to reduce this, it wouldn't reduce because 16 and 35 do not have any common factors, so negative 16x over 35 is your final answer. So for number 19, we have 3 fractions, but again, the process will be exactly the same. We'll just have to write out a list of 3 multiples instead of 2. So I take all 3 denominators, 12, 6, and 9, and write the first 5 multiples of each. And if I look at my list, I don't have a match between all 3 rows, but if I add one more number to 6's list, I get 36, which is in all 3 rows. So my least common denominator is 36. So starting with 12's list, 36 is the 3rd number, so I multiply it by 3. On 6's list, 36 is the 6th number, so I multiply it by 6. And on 9's list, 36 is the 4th number, so I multiply it by 4. And when I take negative 5w times 3, I get negative 15w over 36 minus 42w over 36 plus 32w over 36. And I've changed all of my denominators into a 36, and now I can write one fraction all over 36. And if I write down my numerator, negative 15w minus 42w plus 32w, I take 2 numbers at a time starting from the left, and since I'm subtracting with negative signs, I do keep, change, change. So negative 15w plus negative 42w is equal to negative 57w. And then I bring down the 32w. And if I take negative 57 plus 32, I get negative 25W. So that I have negative 25W over 36. And if you wrote the prime factorization of each number, you would not have any common factors, so this is the final answer. And the last problem, negative 36 over 5W plus 8 over W, and W is the same as 1W, so if it helps you can write the 1 in. And when I list the multiples of 5 and 1, the least common denominator is 5, and I only have to multiply the second fraction by 5 because the first fraction already has a 5. So that I have negative 36 over 5W plus 40 over 5W. And I can now write this as one fraction, which is 4 over 5W. And 4 and 5 do not reduce, so this is your final answer.